So in today's class, we will learn about ILATE. ILATE is a rule that we use to do integration by parts, and we use ILATE to decide that which function should be assigned as u and which function should be assigned as v prime. Okay, so ILATE is nothing but an acronym which stands for, here I stands for inverse trigonometric function, L stands for logarithmic function, A stands for algebraic function, T is for trigonometric function, and E is for exponential function. So the rule of ILATE is, if you have to integrate, let's say, I'm going to take this example. If you have to integrate this integral, this is the product of two functions. First function is x cube, second function is log x. Now this x cube is an algebraic function, or we can also say it's a polynomial. Log x is a logarithmic function. So we will look at ILATE. Whatever comes first in ILATE, that will be assigned as u. So we are going to follow this sequence to decide which function will be assigned as u. So whatever letter comes first will be u, and whatever letter comes after that, that will be v prime. So now we see that L comes before A. So L will be my u and A will be my v prime. Once we have assigned the given functions as u and v prime, we just need to find out a couple of more values. So we know that u is log x, so u prime is 1 over x. V prime is x cube, so its antiderivative is x raised to 4 over 4. And then we will just put all of these values in the formula of by parts. And we will get this answer. Now we will look at two types of integrals where we will know that we have to apply integration by parts. This is type 1. In the type 1, you will see, if you see any problem which is of this type, e raised to the power ax times sine bx or e raised to ax times cosine bx, if you see a problem like this, you have to apply integration by parts twice, not just once, but twice. Because what will happen is, when you will integrate this type of integral two times, then you know that integration of sine is cosine and integration of cosine is sine. So you will realize that you will get the integral that you started with. You will get that integral again. Okay, so in order to make our work easier, what I'll do is, let's say we have this problem. We have to find out the integral of e raised to 2x times cosine of 3x plus 4. So now I know beforehand that when I will integrate this function twice, then I will get this exact expression. So instead of writing this expression again and again, I will say that let me assume that whatever the value will be, let's say that the value of this integral is I. Okay, I'm saying that value of this integral is I. Now we will apply integration by parts. So this is exponential function, this is trigonometric function. We will look at the sequence of ILATE. Okay, so t comes first and e comes after t. So t, that is my trigonometric function, that will be u, and exponential function will be v prime. So my cosine of 3x plus 4 is u and e raised to 2x is v prime. So u is cosine of 3x plus 4, so u prime will be negative 3 times sine of 3x plus 4. And my v prime is e to the power 2x, so its antiderivative will be e raised to 2x divided by 2. Then we will substitute all of these values in the formula of by parts. We will get this. Now this 3 over 2 will get outside of the integral. Notice that here is a plus sign. but originally it's a minus sign in the formula. But since u prime is also negative, so that negative and negative becomes positive. Now 3 over 2 will come outside of the integral. Then we notice that we are again left with this type of integral. So now we will apply integration by parts one more time. And when you will apply it one more time, for this integral, you will get these two terms. Now, after applying by parts to this one inside the green bubble, you will get these two terms, and you will realize that this term inside the white bubble is nothing but I. It's nothing but the original question that we started with. Okay. So now we actually started from I. In equation 1, we started from I, and we got this term. So I've written this exact term over here, then plus 3 over 2, and then this. Then we have solved for this. For this, we are getting this term and this term. So I've written exactly this. E to the power 2x over 2 sine 3x plus 4 minus 3 over 2, and this is nothing but I. So minus 3 over 2I. And then you just have to simplify these terms because now everything is outside of the integral symbol. Now we will just have to do some algebraic manipulation, and finally we will get this answer. So this was type 1, where you have to apply integration by parts. And here specifically you will apply integration by parts 2 times. Now let's see the second type of problem where you will have to apply integration by parts. This is this type of problem where you'll have e to the power x, and it will be multiplied by sum of two functions. This is sum of two functions. And you will see that the second function is actually the derivative of the first function. So if you get a problem like this, then you will apply integration by parts. For example, we have this problem. This is e to the power x multiplied by cosine x minus sine x. Now here if we see, derivative of cosine x is actually minus sine x. So we have, if this is fx, then this is f prime x. Actually, do not get confused with the negative sign over here, because let me write it in other way. Here this is plus, but this is also plus. But what is happening over here is this is cosine of x plus, this is cosine of x plus negative of sine x. This is cosine of x plus negative of sine x. So if this is your fx, then this is f prime x. Okay. So now what we will do is we will distribute this ex inside the parentheses. We'll get e to the power x cosine of x minus e to the power minus sine x. So I'm just distributing e to the power x. And then you will apply integration by parts to both of these integrals, and you will realize that two terms will get cancelled, and finally you will get this answer. Here is another problem where you have, this is another problem of this type. So if you can see clearly that this 1 over x square, if we assume that this is f of x, then negative 2 over x cube is f prime x. Again, here do not get confused with this plus sign. This is plus sign and here is minus sign. So this is actually e to the power x 1 over x square plus negative of 2 over x cube. So this now, if this is f of x, if this is f of x, then is actually this is actually derivative of fx. Then we will again distribute e to the power x and we will apply integration by parts to both of these integrals and we'll get the final answer.